This one is C5H12ONCl. That would have 0 double bond equivalents. We have a 2H, 2H, 2H here. Now that suggests 3 CH2s. Now you might be thinking, well, this is a single peak, so perhaps that could be an NH2. Well, I'd say that since there's no designation that it's broad here, I would be more likely to say if it's probably a CH2 if it's not adjacent to anything that's got hydrogens on it rather than being, say, an NH2. So I'm going to leave that as being a CH2, so that's 3 CH2s, and we have 2 CH3s as well. And then what we'd have left here is an N, an O, and a Cl. Cl, O, and N. So this should be the number of pieces we have. Now looking at some of the information we can get from this, we know that we have two CH2 groups and that they both have 3 peaks. So we've got a CH2 that's got 3 peaks, so it's next to 2 hydrogens, or a CH2, and then we've got another CH2 that's got 3 peaks, so it's probably next to a CH2 as well, and we could probably posit that those two are next to each other. Now I don't know what's next to what, but because it could be B next to C, but I'm not 100% sure yet. I'll figure that out as I go. But one thing I do know is that the CH2 can't be joined to the other side of this CH2, because what would happen then is this CH2 would appear as 5 peaks being adjacent to 4 hydrogens. So I know that these two CH2s are together, but they're apart from everything else as well. Now looking at some of the shifts here, we can get some clues as to what these things might be connected to. Now I can see that we have a CH3 that's at around 4 ppm. According to my correlation chart, a CH3 at around 4 ppm is probably connected to an oxygen. So I'm going to go ahead and connect the CH3 down here to an O. Now we have also a nitrogen and a chlorine and another CH3 to put into the mix here. Now what I can see is that this CH2 here is at 5 ppm. That generally indicates that we've got something that's connected to a couple of electronegative groups. As I said earlier, things connected to oxygen usually appear around 4, but when you've got 2 electronegative groups attached to an atom, it generally tends to move things downfield even further than what you'd expect. So I could be fairly sure, for example, this CH2 was going to be connected to probably both an oxygen and a nitrogen, or an oxygen and a chlorine. So I'm not going to say which yet because I'm not 100% sure. I'm going to try and get some other clues by looking at what we see here. I see that we have a CH2 and it's around 3.5 ppm. That's a fairly typical placement for a CH connected to, say, a bromine or a chlorine. So I'm going to say that the Cl is connected to the CH2, and I'm going to go ahead and put that on the end, which means it's probably going to be connected to the one I've marked as C, the one that's going to be furthest over to the right hand side. And I know that that particular one that's at 3.6 ppm is also connected to another CH2 because it's got 3 peaks. So I'm fairly confident in this arrangement that I have here. Now I know that the CH2 can't be connected to this CH2 for the argument I gave you earlier. So I'm going to go ahead and stick the CH2 here and stick the nitrogen down here and put the CH3 connected to the nitrogen like this. So I'm going to suggest that that's probably the way that the structure is worked out.